Hello, my name is Charlie Gusson, and today I will be talking about RAM and Riemann sums. Riemann sums are a method of approximating the total area under a line in a function graph. LRAM uses rectangles with the leftmost point of the function, as seen in the diagram below. It tends to underestimate the area when the slope is positive. Alright, here is a problem solved using LRAM. As you can see in the visualization on the left, the rectangles are very small and do not include a lot of the space of the shaded region. RRAM is similar to LRAM, except it uses the rightmost endpoint. So for positive slopes, it tends to overestimate the area of the shaded region under the line. So you can see the rectangles cover a lot more area than the actual shaded region in this example. MRAM is similar to RRAM and LRAM, except it uses the midpoint for each rectangle, so it tends to be very close to the actual area of the shaded region compared to RRAM and LRAM. As you can see in the diagram, it covers up a similar space to the shaded region compared to RRAM and LRAM, and it also has a kind of mid area between the RRAM and LRAM values. Alright, today we will be approximating the area of the shaded region using LRAM. So for this one, it is the area under the line y equals x squared. So first we will be setting n equal to 4, and that's just the number of rectangles we'll be using. So the first rectangle will start at the leftmost point, 0, then it goes across to 2, so it doesn't have any area. The next one starts at the leftmost point, starting at 2, and then across, and then 2 squared is 4, so that's the notation for there. The next one will go up from 4, and across, and then 4 squared is 16. Do with that. And then the last one will be 6 across, and 6 squared is 36. That's what you get for those. And just to write it in algebraic terms, you get the area equals the sum numbers from n, or from u, equals 1 to n. And that is the change in x times the function of x starting at u, which is 1. Okay, so the change in x equals b, which is right here, 8, minus a over n, and then we already said is 4, and a is 0. So then we get 8 minus 0 equals 4, which simplifies out to 2. And then let's just rewrite it. Area equals change in x times, let's write it out fully, so f2, using LRAM, so f of 0 plus f of 2 plus f of 4 plus f of 6, and then all of that times 2. And then we can plug in our numbers. So change in x equals 2 times 0 squared is 0, plus 4 plus 16 plus 36. And then that simplifies out to 56, and then times 2. So we get the area equals 112.